So today's problem is one of the most powerful problem and most popular string problem in the interview. Longest substring without repeating characters. At the first glance, this looks simple. You are given a string and your goal is to find the length of longest substring that contains no repeating characters. But here is the catch. A brute force solution exists, but it's slow and inefficient. In interviews, if you try the native approach, it can easily lead you to n square time complexity. So how can we solve this in big O of n time? That's where one of the most important DSA patterns comes in, the sliding window technique. In this video, we will break this problem down step by step. First, we will understand the brute force approach so the intuition becomes clear. Then we'll optimize it using sliding window pattern, which is a technique used in many real interview questions. By the end of this video, you not only solve this efficiently in Java, but you'll also understand a powerful pattern that appears again and again in interview. So let's jump in and solve longest substring without repeating characters. So if you see the problem here, we need to find the longest substring without repeating character, and we have to just return its length. That can be simple or multiple, but we just have to return the length of longest substring without duplicate characters. In this case, ABC, BCA and CAB are the candidates, but if you see the length, it is 3, so we just have to return 3. Let's deep dive into the coding part and let's try to solve it in brute force manner. So first we take the variable of max length that we return at the end. We take a for loop to iterate over each character of the string, and we take a head set to store each character, and set will only store the unique characters, and we also take a for loop within that for loop so that we'll try to check every possible substring. So if you see this from the beginning, and by applying the for loop within the for loop, we can expand the possibility of unique unique substring. If any character we received as duplicate, we will just ignore that and we will start again from after the previous substring we found. So in the same manner, we'll do this. So we'll take every character and try to check if it is a candidate of that, and if that character already in the set, we will just break this for loop and we'll try with different substring. And if that is not the case, then we will add that into our set. Every time we will try to calculate the max length to check if the current given length is the maximum or the newly calculated length is the maximum. And at the end, we will return the max length. Let's try to run and let's see. So this is returning 3, that is what we are expecting. Now let's try to optimize this. So if you see this optimal solution, instead of checking for every possible substring candidate, now we'll introduce this variable length sliding window, and we will expand the window as long as we are getting non-repeating characters. And once any character repeated, we will try with different window. So now let's see this action, how this optimal approach work. So we will taking a HashSet, and for creating a dynamic length of window, we are taking 2 pointers and a max length. So first pointer start from 0 and second pointer will taken care by the for loop. So this is right pointer taken care by the for loop, and both we will starting from 0 and we will expand and try to check if the current window is containing non-repeating characters or not. And while the current for loop is getting the characters what is already present in the set, we will keep on removing the left part because we have to maintain the continuity also, and we will keep on increasing the left. So now you can imagine we are trying to check if something is already there in the window or not. If it is there, we'll keep on increasing left pointer until we reaches to a point where the new character that we found using right is not in the window. So in this way, we will take care of the dynamic window. And once we found out that the right variable is getting a correct character, we will just add that. Also, we will calculate this max length every time as we have done in the brute force approach. And at the end, we will just return this max length. So how this will help is we don't have to go through and check for every possible combination of substring. We can try to do this. We have already achieved this in big O of n complexity. Let's paste this in LeetCode and try to check if it is work or not. So I have pasted and I'm running. Let's see. So it passes all the test cases. Now let me submit this to test for all the other test cases also. It is now beating it 69% of the programmer out there. And that's how we solve longest substring without repeating character, using the sliding window technique. We started with the brute force approach. We check every other possible substring and it gives you n square time complexity. Then we optimize the solution using sliding window and reduces the time complexity by big of n. What exactly an interviewer expect? This problem is a great example of how recognizing a right algorithm or algorithm pattern can dramatically improve the performance. If you are preparing for coding interview, make sure you master pattern like sliding window, 2 pointers and hashing. You can watch my video for the same, because many problems are just variations of these core ideas. And I'll see you in the next one.